So this is our wildlife trail cam 2 that is. This is the base station and the monitor that shows what the trail cam sees. And as we pan over here, this is the receive station. This is where the photograph that's taken by the base station will pop up after about 15 minutes. So we'll go ahead and get rolling here.
So this screen is showing what the camera sees at all times, and the NTSC signal comes out of the camera and feeds into the video input on the DE2 board, where it is digitized, downscaled to 160 by 120, and then sent to a frame buffer. And the software processes frames looking for motion as soon as one of these lateral motion detectors sends a signal. So the idea is that an animal approaches the system from the left or the right, one of the motion sensors goes off, triggers the camera to wake up, start capturing images, and then starts looking for motion in the field of view. And the way that's done is through a method of frame differencing, and what this screen shows is simply the chroma difference between consecutive captured frames. So when there's no movement in the field of view, the screen's going to be black. But when there's, I put my hand in front, then you can actually see an outline of whatever's in the field of view, and then when you be very still, then there's nothing. So the number of pixels that are different in consecutive frames is a measurement of how much movement there is, and once the system reaches a threshold, it decides that there's a target of interest in the field of view, and then it switches to another mode where it will be capturing differences between a reference image. If I can get out of the reference image, that would be good. So this is the image that was seen when the motion sensor first triggered. There's actually nothing going on now. And then this is showing the difference between the reference image and what's currently in the field of view. So now this is what the system would see when an animal actually approaches the field of view. And so only the pixels that are different are shown in this frame. So the system in operation works like this. I'll take the channel back. So now the system is actively looking for motion. I've actually triggered the motion sensor by just being here. And the rabbit is going to enter the field of view, and then the system will detect it and then calculate a centroid, which of the item that's moving, and that's basically a calculation. We actually do that in hardware for speed instead of trying to do that in software. And so the nice thing about a centroid is that it will it's relatively immune to stray pixels or blobs of pixels that are the same color as the target. So basically the stray pixels get filtered out, and you end up with the ability for the system to track pretty reliably across there. So the idea is that the centroid that's calculated and shown in the yellow crosshairs, that is fed into the servo control system, and the idea is that the difference between where the crosshairs are and where the center of the field of view is the error signal that the control system uses to keep the centroid in the center of the camera's field of view. So if I restart the system and enable the photograph to be taken, let the system restart, and now it's waiting for a motion sensor to trigger. So now the rabbit enters the field of view, the camera sees it, and when the system is close enough to a reasonable target, where it's close enough to the center of the field of view, the camera takes a photograph, which is the flash you just saw.
So then what happens?
Then the picture is stored onto the compact flash card on the camera and then transmitted to our receive station over here wirelessly.
And how long does it take? Well, what are the timings for this?
Currently, the camera's somewhat old technology, and so it takes, at full resolution, takes about 40 seconds to copy the image from, just for the camera itself to store the image to compact flash. This is the system, the DE2 board downloading the image that was just captured from the compact flash card.
Okay.
Once that image is downloaded, then it will transmit that across wirelessly to the receive station. And this is, unfortunately, this part is rather slow. The serial port tops out at 115.2 kbaud, and so we've got what is a 9 megabyte image to download, and so it's rather slow.
Okay, how long does it take to get from the base station over to the receive, to be transmitted wirelessly over to the receive station?
Once that's done, we get the image across in just a few minutes.
Okay, so we will cut at this point and pick it back up when the receive station has received the image. So it's been about 15 minutes or so since we took the photograph on the base station. It's been it took a little less than 15 to get it downloaded from the camera to the base station, and just a couple of minutes from the base station over to the receive station, and the image has popped up on the screen showing the photograph that was captured by the tracking camera. And we'll zoom in a little bit. So there's the wireless unit sitting on top of the board. That is our receive station, and there's the image, and the image itself shows weather information. There's our weather information that comes up from the weather station that's on the base station, and that's about it. That concludes the demo for our TrailCam 2 and the ECEN5633 Hybrid Embedded Systems class.